Well, good morning, everybody. I hope that you are ready to start math. Today, we're going to get into a lot of building of multiplication arrays. This means that you will need those little bags of yellow base 10 pieces that you had yesterday. When I left class yesterday, everything was put into the red square bowl that was put inside of the blue cloth bin that was near my desk. I'm not certain if it is still there or not, but you may need to pause the video to find those base 10 pieces. Those of you at home, you will also need your base 10 pieces unless you are choosing to use the Number Pieces app. Okay? So before we get into that, let's think about what's going to happen today for our lesson. So we have the story of the garden ants. Let's enlarge this so we can read it. And it says, Mr. and Mrs. Ant and their two children, Andy and Amber, are already planning their garden for next spring. Help them decide how much space that they will need for the things they love the best. So, as we think about this, I want you to think about what each problem is going to ask you to do. We may need to do some estimates. Remember, estimates are numbers that are close to the exact amount, but they don't have to be the exact amount. And then we'll start working through this paper. So, on number one, it says Mr. Ant loves strawberries. So, he wants to put in a new berry patch that is 12 centimeters by 14 centimeters. What is the area of the berry patch Mr. Ant wants to put in? So, looking at this column, it says, what is the problem asking us to do? Think about that. What is it asking us to do? While you are figuring things out, I'm going to put this on pause and I'm going to type something as okay. So after you had your quick little discussion, did you come up with the same idea that I did, that the problem is asking us to figure out the area of the berry patch? So now I want you to think about a reasonable estimate. Now, estimation is really hard for some people because a lot of us want to have the exact answer. So when we talk about reasonable estimates, we want to take what we know to get an answer that is close to our a possible answer. So if we look at what we have here, 12 centimeters by 14 centimeters. Well, we know that we're talking multiplication by listening to the language. We're looking for the whole area. So to find the area, we have to do some multiplying. And off the tops of our heads, we don't know what this is, although I'm certain some of you are trying to figure it out. So right now, I want you to discuss some possible ways of figuring out a close number, an estimate, an easier to use number. Pause the video while you discuss this. Okay, so maybe some of you thought of this, that it's got to be greater than 100 square centimeters, because I see I missed the E on because 10 times 10 equals 100. Okay, so we know it has to be greater than 100. So that's a reasonable estimate. Maybe some of you were thinking that you knew that it had to be 144 square centimeters because 12 times 12 equals 144. I don't know what other kinds of estimates you had. Maybe you were thinking of looking at 12 times 14, that maybe you could think of 10 times 14, because that's something we practiced yesterday, that 10 times 14 would be 140. So those are just two of the examples that you could possibly use. Now we have to actually figure this out. So I'm going to use our number pieces so I can figure this out for you. Let's first of all think of what our equation needs to be. And that is 12, where's our multiple, times 14 equals. That's what we're working on. So let's move this off to the side and we'll worry about that later. And now let's think about all of these pieces, how to make such a thing. Well, I can look at these numbers and, this is going to be a little bit difficult. If I look at this, maybe I need to think about my base 10 pieces and that I need to make a 12 going down and I need to make a 14 going across. Well, I can already see I have a 10 plus 2 and a 10 plus 4, so I can use one of these. If I think about how much this is, I know that this side right now is 10. So I put, and we up here, I know that this much is, I hope you can get that figured out before I have it typed, 10. Okay. But that's not what it asked us to do. It wants us to have 12 by 14. So how do I do this? 10 by 14. I've got a 10. Remember yesterday even, we were seeing them draw these lines. Let's see if I can get a straight line drawn. Where it was, oh, that's not a straight line. Let's try that one more time. And, oh, they got a straight line drawer. So let's see if we can do that. So if I have one of these, remember in our book yesterday, we knew that that meant 10. And if I make one of these, that means 10. And now I need to have this one be a 12. So I need one of these little guys and one of those little guys. And then I need this one to be 14. So let's have 1, 2, 3, 4. I know they're crooked. I'll get better at this. So I need to fill those things in. So let's grab some of these. Let's see. Let's put this one here. And this one here. Okay. So that gives us a 10 and 2 more. So that's a 12. Let's get a 2 down there. Put our 2 right here. Okay, now we need to put 1, 2, 3, 4 of those. Let's put a 4 up on top. And let's match up some of these long ones. 1, 2, 3, 4. Let's move them. So here is 1. And let's move this one. Let's move this one. I guess my little lines are too long. I suppose I could put them underneath the lines so that we can see the difference in them. Okay. We'll do that with this one too. So we can, it doesn't want to go down there. There it goes. Well, we got an empty space here. That's not going to work. But we can use these little guys. So let's fill this stuff in. We know that arrays make rectangles. Let's fill that in with those little bitty guys. Okay, so we need some of those. 1, 2, 3. Let's start sticking them down here. So there's 1. And there's another one. Oh, let's change their colors so that everything is easier to see. And, oh, I lost it. I guess the colors don't want to change. So let's put this here and this one here. Looks like we need one more. Okay. Oops. There we go. Now we need to see what we have up here. It's kind of like missing. So let's draw a line so we can see. Okay, so there's the separation and there's our separation. And so now we can see the different parts that we have. So if we think about this, I know we've been doing 10 times 10. So what is 10 times 10? Okay, let's put that in black. Okay, done. And we know that 10 times 10 is 100. Now here we have a group of 4, and they're 10 long. So we have 4 times 10. 4 times 10, we can count by tens, but 4 times 10 is 40. Let's make it black. Okay, we're done. There, we know that this is 40 over here. Now we have these 2 pieces here. Each of them are 10 long, 10 little guys long. So 10 times 2 is 20. Let's move that down here. And what do we, oh my goodness, now we got to count these things. Let's see, there's 1, 2 going down by 1, 2, 3, 4. Well, look at that. Over here's a 2. And see what? See, there's 1 here and there's 1 there, just like the 2 over here that's blue. And look up on top. There's our 4. 1, 2, 3, 4. We have this little bitty array right here, a 2 times 4 array. What is 2 times 4? Okay, I know somebody must have said it already. Oh, I forgot to make it black. Well, we have one of them that's blue. So now we have all of these numbers to add up. So let's add them up. We have 100 plus 40 plus 20 plus 8 equals, and now we have to add this up. 100 plus 40 plus 20 plus 8. So I know some of you look at the different numbers and try to find combinations that are easy to deal with. So 20 plus 40 plus 20 is 60 plus 8 is 68 plus 100, 168. 168. So we added that all up. So what is 12 times 14? It is 168. Okay, so moving back to our board, what is our answer? It is 168. It's kind of big. Make it smaller. There we go. Okay, moving on to number 2. It says, Mrs. Ant loves vegetables, so she wants plenty of room to plant them. She says she wants the vegetable garden to be 11 centimeters by 13 centimeters this year. How many square centimeters is that? Which means now we have to answer these questions. What is the problem asking us to do? And what are some reasonable estimates that we possibly could come up with? I'm going to pause the video while you think about this. So the questions you're answering, what is the problem asking, and what are some reasonable estimates? Okay, I'm thinking it did not take you very long to figure out that this time we're figuring out the area of the vegetable garden. So if our dimensions are 11 by 13, we need to build such a thing. So here is our number pieces. And remember, before we had these straight lines, we know that if we draw a straight line, that's going to be a 10, and that's going to be a 10. So let's see how close we are to grabbing a 10. Ooh, I made that one a little bit long. So let's do a little bit of erasing on it. There we go. Okay. Making this just a little bit longer. There we go. There's our 10 and our 10. I'm going to write it 10 above because that's faster than typing it. Although maybe it doesn't look as nice. But we need to have a 13 by 11. So we know that to make this a 10 into an 11, we need to put our little line there. And 13 would be 1, 2, 3. So let's put a 3. Maybe I should type after seeing that. Okay, so it's saying that we need one of these. Let's put it down here. Okay, so that gives us 10 plus 1, which is 11. Now we need to make this one 13 across. So now we're at 10 plus 1 is 11, plus another one is 12, plus another one is 13. So across here, if we counted, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 10 plus 13 equals 13. 10 plus 1 equals 11. Oh, wait, we don't have anything on the bottom. Remember, we are looking at, let's use a different color. Let's do blue this time. Remember, we have our group, we have our mat, our 100. So 100 goes in the middle there because we know 10 times 10 is 100. We've been talking about that for long enough now. And we have one group of 10, which 1 times 10 is 10. Okay, we'll put that down here. We have 3 groups of 10. 3 times 10 is... I hope you're saying these to yourselves as I'm getting everything out to type them. But we still have this. Remember our array, we need to have a square or a rectangular array, and we have some things missing, so we need to add these little pieces. So there's one, there's another, and there's the last one. Look at that. Everything fits in very nicely. So how many of these do we have? I think you can count them. I think you can see them. We have 3. Oh, look at that. Our 3's right there. So if we were going to pull these out and add them up, we have a 100. We have a 30. We have a 10. We have a 3. Not lined up the best, but it'll work. Let's get these a little closer so we can add them better. Okay, so let's draw a line. We're adding. Okay, all of them in my ones column, all we have, oh, that doesn't work. Adding that up, 0, 0, 0, 0, and 3 gives us a 3. Now we have a 0, a 30, and a 10. 30 plus 10 is 40. And then we have a 100 with no other 100s, which gives us an answer of 143 square SQ centimeters, CM. Remember, we talked about this a few days ago, that all of these little squares, each of them is worth 1 centimeter, and they form a square, so we call them square centimeters. Now, going back to our paper, we looked at this to figure it out, and we thought about that if we were going to do an estimate, we would have it bigger than 100 because we already know 10 times 10 equals 100. We knew it would be bigger than 130 because 10 times 13 is 130. So when we actually figured it out, we found out it's 143. So please realize again that we are doing reasonable estimates. And when we do a reasonable estimate, we're just trying to figure out an answer that is close. So we knew that, well, 100's, it's kind of far away, where 144 is a little closer. With this one, 100 kind of works, but we've noticed that 130 is a little closer. So now these next two, do you think that you can try figuring these out on your own? Working with your table partners, see if you can figure these out. I'm going to do put some answers in, and I want everybody to have a discussion. I'm thinking that when it comes to asking what this problem is asking us to do, we already know that we're going to have an apple orchard, so we want to find the area of the apple orchard. And this one says Amber loves to sit on the front porch of the farm in the spring, and the porch is 11 by 21, so we have to find the area of the porch. So I will be back with you to check on all of these just in a little while. So you keep using your base 10 pieces and see if your table groups can figure these out. Okay, you've had a chance to work on things, and I hope you've used your base 10 pieces to figure this out. So we know that we are figuring out the area of the orchard, and we're figuring out the area of the porch. So if we look at what our estimate could be, we're thinking about that the area needs to be bigger than. Remember, this little symbol is greater than. When it's shaped the other way, like an L, it's less than. So here we have greater than 144 square centimeters, because 12 times 12 is 144. Or maybe you thought about it as 10 times 15, and 10 times 15 is 150. So we know it's larger than 150. Okay, so let's work through it to find out what actually happens. Okay, as we start to build this, we know that we have to have one of our sides that is 12 centimeters long, and one of our sides it has to be 15 centimeters long. And we know inside of our 12 we have a 10 plus 2. We also have inside of our 15 a 10 plus 5. So when we pull one of these out, we know that we have a 10 and a 10. So now I'm going to put this on pause, and I'm going to build everything, and then we'll talk about it again. Okay, I went ahead and made our array. We were talking about a 12, which is a 10 plus a 2. So here's my 10 plus my 2. 10 plus 2 is 12. So if we would count all the way down, we would see that there is 12. And then we know that 15 is 10 plus 5. So you can see my 10 plus my 5. So if we add 10 plus 5 together, it's 15. If we count all along this top row, you can see that we would have 15. Now that we have the dimensions, we're able to multiply our hidden arrays, the mini arrays that are inside of this array. So we know that 10 times 10 is, and I hope you knew that one, put it right in the middle. So now we have a group of 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 times 10. I don't need to write 10 right here because I have 10 on the other side. And I know that in a property of a rectangle, however long this side is how long this side is. So I don't need to count that. I just know that this array is 5 times 10, which is 50. So we'll move that into this array. Now when we're looking at these long skinny arrays, I know that I have 2 rows of 10. 2 times 10 is, oh come on, here my mouse is being silly. There we go. So we know 10 times 2 is 20. And now here is the part that tends to get fourth graders mixed up. We can see how to multiply the 10 times 10 equals 100. We can see that this is 2 times 2 groups of 10, so 2 times 10, which is 20. We can see that this is 5 groups of 10. 5 times 10 is 50, but we can't see what this is so well. So we really have to think about this like a multiplication chart. Just like a multiplication chart, we follow it over. So we have 2 rows, which we can see. And then it shows us that we have 5 columns. So 2 rows of 5. 2 times 5, which equals, and you should have that number said before I even get it typed. Here we go. So now you see where we get all of these squares. When we add all of these squares up, we get our total area. So we have 100 plus 50 plus 20 plus 10. So when we look at that, 10 plus 20 is 30, 30 plus 50 is 80, 80 plus 100 is 180. So going back to our problem, we know that 12 times 15 equals 180 square centimeters. Okay, and then moving on to our last one. Amber Ant loves to sit on the front porch of the ant farm, and their porch is 11 by 21. That's pretty big. What is the area of their porch? So we think about it and we know that it's bigger than 200 square centimeters because when we were estimating, we could look at the 11 and think, okay, well, 10's easier to work with. We can look at the 21 and think 20 is easier to work with. So 10 times 20, 10 groups of 20 or 20 groups of 10 equals 200. So when we figure it out, we will find out what exactly 11 times 21 is. I'm going to set up our next array and then we'll work through it. Okay, so after we set everything up, we knew that we had to have an 11. So 11 is a 10 plus a 1. 10 plus 1 equals 11. We could count down. We could see that there are 11 rows of centimeters, 11 rows. So looking this way, we could count them, 11 rows. And now thinking about our columns, we have the number 21. We have 21 divided as a 10 plus a 10 plus a 1. When we add these all together, if I would move these all together to make one array, oh no, I lost my numbers. You can see, oh, that's my number 1. You can see where our numbers come from. 1 times 10 is 10. 1 times 10 is 10. 1 times 1 is 1. And now I have a row of 10 going on right here. Oh, here it is. And then we have a missing 100 underneath there. So we'll just make another one. It went to the back. Okay, so we're adding up a bunch of sections. 10 plus 10 plus 1 is 21. So if we add those up, we have a group of 100 plus a group of 100 plus a group of 10 plus a group of 10 plus a group of 10 plus a group of 1. And when we add all of that up, we have a 1 plus 10 is 11, plus 10 more is 21, plus 10 more is 31, plus 100. 31 plus 100 is 131, plus another 100 is 231. So again, all of these little pieces work together when we're making our arrays. I've separated them like this so that you can see how I broke the tens and ones apart. Here we have a 10, and the ones broken apart. So if we peek at our answer, we have 231 square centimeters. Now, continuing to work on this, these are already pre-made. So let's zoom in on this. And here is our first array. Looking at these garden arrays. Let's see if I can get it all to show. Oh, it doesn't quite show at that magnification. So we'll have to go right here. When we look at this, we can see that we have one of these. It's too big, so I can't use it. But you can see that this is a 100. This is a 10 and a 10. We have a 10, a 10, a 10, a 10, and then look at all these little ones. So if we were going to write on this to show us our groupings, we have a group. Don't know why I have a dotted line. It didn't want to. There we go. I must not have grabbed it good enough. Okay, so here is our first group. You can see that we have a 10 by a 10, and we know 10 times 10 is 100. I'm pretty certain you understand why I was really drilling in what 10 times 10 is. So next we have a 1 and a 1. So 1 plus 1 is 2. I'm going to circle that in a different color. So you can see that we have this group. And it is 10 times. See the 10 up on top? The 10 is showing us that there are 10 across, even down here. So 10 times 2 is 20. Now we're going to look at this group over here. Let's pick a different color again. Okay, so we have 1, 2, 3, 4 of them. And circling that group, I have 4 groups of 10. 4 times 10 is 40. And our very last group, let's make that one green. So we have this little bitty group right here. Notice that the 2 gives us 2 rows. Notice that the 4 gives us 1, 2, 3, 4 columns. So we have 2 times 4. 2 times 4 is 8. Then when we pull our numbers out to add them, we have a 100 plus a 40 plus a 20 plus an 8. I hope you can see where these numbers come from. Here's our 100. Here's our 40. Here's our 20. Here's the 8. And adding that up. 0 plus 0 plus 0 plus 8 is an 8. That 8 isn't looking so good. Then a 20 plus a 40 plus a 20 is a 60. And they won a 100 plus nothing gives us 168. Okay, looking at this next one. I want you to see how we have 11 times 13. It's what we've been already working on. Here is our 10 with our 1, our 10, and a 1, 2, 3. We have 13 on the top. We have 11 on the side. We worked this out once already so that you can see how we changed it into a 10 plus a 1, and we changed our 13 into a 10 plus a 3. Notice then that we multiplied this side, the side times the side, a top times a side, which is 100. So we did a 10 times 10 equals 100. When we look at this, we are doing 3, there's our 3, times, how long is this? It is 10 centimeters long, so 10 times 3 equals 30. When we look at this little row down here, we have one group. There's only one in its row, but there are 10 of them. So 1 times 10 equals 10. And remember, this is the area that messes fourth graders up, this little bunch right here. We've done this part, and we've done that part, and we've done that part. Now we have to do this part. So we have one group, which is one group of 3. 1 times 3 gives us 3. Then we add these back together, because if we need to have an 11, we have to add this plus this, which means then we have to add what's on the inside too. So we have to add 100 plus 10 is 110. Looking over here, we have our 10 plus 3 to get 13. So now we have this column to add, which is 30 plus 3, which is 33. And then when we add them, that brings us to 143. Okay. You've seen these again. This is what we were working on earlier. I showed you what I built using the base 10 pieces. Oh yes, if you can hear Moose, she's talking to me again because she just thinks it's bad if I'm talking to myself. She doesn't know I'm talking to all of you. So here we go. Again, here's the 12 on this side. You can see that this long line represents 10, 11, 12. Here is the 10, 11, 12, 13, 14, 15. So that's how we break 12 times 15 apart. So that 10 times 10 is 100. Here we have 2 times 10, which is 20. 5 times 10, which is 50. And then this last little part that causes third graders problems, this part right here, we have 2 over here. 1, 2, 3, 4, 5. We have 5 on top. 5 times 2 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then we would add this part, and this part, and this part, and this part to get our final sum. This is, again, how we broke apart the very last problem, the problem with the porch, how we had 21 divided into 3 groups, a group of 10, a group of 10, and a group of 1. Going down, we have a group of 10 and a group of 1. We added all of those parts together. So that brings us to our workbook. Let's look at what our workbook is showing us. It says you're going to build each array, and then you're going to write an expression or an equation. An expression means that it is like 4 times 5 or 7 times 8 or 15 times 10. Did you notice I didn't say equals? As soon as you put an equals, we have an equation. equation. Remember equation and equal, they all start the same way. So you're going to write your expression or equation to show how you found your product, and you're going to record the product in the last column. Now, this is something you'll have to do in class because there are several ways to do it. But for most of you, I would figure that you would break these apart into groups of tens and ones. If we're going to break 14 apart into tens and ones, what is 14 broken apart? Okay, so I hope that you know 14 is 10 plus 4, correct? So you're multiplying that times, and what is 11 broken apart? We know that it is 10 plus 1. That's something you can write. You don't have to write that. Maybe you are going to write some addition equations to help you figure this out. But however you're going to figure it out, that's what you do. So if we were going back to this, and let me clear everything. I got rid of some of it. Let's get rid of some more. And let's get rid of that one. Well, I guess I didn't do a good enough job. And this one. Our paper says I need to build something that is a 10 plus 4 and a 10 plus 1. So I know that this is a 10 and a 10. And remember, it says a 10 plus 4. 1, 2, 3, 4. Move those over here. Or you're going to just use your base 10 pieces, which probably are faster than using one of these. And plus our 1. And remember, we got to make this an array. It's got to be an array. So if I move these all close together, can you see I still have to add some units on the bottom to make this array? 1, 2, 3. Let's see if that's enough. Oh, looks like we need one more besides this one. There we go. I'm going to slide this up. I'm going to slide these up. And I'm going to slide this one over. And that can help us see this a little better. Remember, we were talking that we broke it apart into a 10 plus 4. Here is my 10 plus 4. And we also broke it into a 10 plus 1. Here's my 10 plus 1. What is 10 times 10? Everybody should know that right now. What is 1, 2, 3, 4 times 10? 4 times 10 is what, everybody? Glad you know, it's 40. And then we have one group of 10, which is 10, and we have one group of 4, which is 4. So if I had my numbers filled in around the outside edge, we'd have our 10 plus 1, and we would, I can't slide this down anymore, so I'll have to write in my array a little bit. So I'll have my 10 plus 4. Remember, we were figuring out 11 times 14. We have 100, we have 40, we already figured out, we have 10, and we have 4. So then we need to add this together. 100 plus 40 is 140, plus 10 more is 150, plus 4 more is 154. So you now have the first one finished for you. Use your base 10 pieces to figure out 11 times 16, 15 times 21, and 12 times 16. If you have enough time, then write a story problem to match one of the combinations above. Remember earlier, we had the little story of the ants. So you could make a little story like that. Okay, once you finish that page, there is another one. There it is. This is the next page in your book. I want you to notice how things are written for this assignment as well. Notice it has these little bitty pieces. Well, it's asking or it's telling you that you don't need to use the base 10 pieces if you don't want to. So if we don't want to, let's make this bigger yet so it's easier to write. We're looking at this and we are going to draw our areas so that it's more like an array. Okay, so it says that we want to draw a box that is like about that long. And then there's this box that's about that long. And this side is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. Do you remember how long this line is that I covered up? Remember, that is a 10. So now we have 4 times 10, which is 40, and 4 times 5, which is 20. So if we were going to add this together, we have 40 plus 20 equals 60. And our multiplication equation, this is the part that tends to throw some students, would be 4 times, and now we have to put these two numbers back together. 10 plus 5 equals 15. Look at the type of problems you're starting to do. So again, fill this in. Fill in your rectangle, fill in your rectangle, count your little pieces where you would have 3 here. Count your little pieces, write your number up here, and we know this is a 10. 3 times 10 is what? 3 times the number over here is what? Add them together, then write your equation. Let's see how you do. Good luck and have a good day.